I'm going to run through the environment and show you guys how you guys can console log things and basically navigate the test environment, give you guys some tips, and then you guys will take the test, which full stack does not look at for admission. It's just purely practice. And then right after this workshop ends, I'm gonna open up the second one, and that one, if you do well on it, then full stack will use that, and if you don't, then you can just apply as normal. Let me find out for you guys how quickly or like what window you guys need to take that second assessment within. Um, I don't think it's I don't think you can push it off forever, but I do think there's a window. But um, yeah, I'll figure out for you guys if you guys have questions on when you can complete the second one by. But yeah, that one, it's a little bit more pressure, but even if you don't do well, it's not a big deal. You can just apply normally. So it's just an extra chance um, that you guys get. So before all that, I'm just going to go over the problems, the recursive problems. And definitely these are challenging. They're challenging for me. I was taking a quick second to look over them, and they're definitely not easy by any means. And if you guys think they're easy, then you guys are in a great place. But yeah, I wouldn't stress too much because for admission, you'll only be really expected to know some a little bit more simple recursive problems. Some of these can get pretty involved, but yeah, let's go through them. So let's see. So for the first one, all systems go. Let's try this guy out. So it's saying that, and if you guys have any questions, feel free to ask. It's saying that we want to traverse a deeply nested object. So this is a really common use case. We don't know how many levels deep, so we can't just use a normal. I mean, we could use something like a while loop instead of recursion, but your traditional for loop might be a little limited just because we don't know what that condition is, that constraint. So recursion is a great problem for loops, for objects of undefined or unknown depth, and also arrays that are nested that we don't know how many layers they're nested. Then recursion is a great tool for that, for those types of problems. So we need to determine if all systems are go for launch. Keys represent the name of the system on the spacecraft. Values are Boolean. Name of the system, but values are Boolean. If true, if the system is go for launch, and false otherwise. Your function should only return true if every system is a go for launch. So we need to go through all these layers, and for each key, there can be multiple nested, an object with keys, and then this key, it's 3 levels deep. So this power only has power.batteries, but telecoms has telecoms.antennas.high gain. And so we need to go through each level and then return true if all of these nested properties are true. So let's see how we can approach this. So yeah, I would say for a problem like this, it's really good to start simple. So a case like this, for example, where we have an object that is the simplest object, only a depth of 1, and doesn't have any nested objects. Let's just start by solving that case first, and then try and get more complicated. So just solving this for this first case, let's see, function all systems go, and this will take in an object, and then it's gonna return true if all of these Boolean values are true. So let's see. I guess we can have, see how we can approach this. So we can have like an outer value that returns, we can set a Boolean default and then iterate through all of the keys, and then check if they're all true. So, and then, yeah, and then iterate through all of the other nested objects if there are. So I'm just going to solve the simplest case first. Let's just go with it for now. So let's just create a Boolean. What should I call this? All systems go. And then I'll just set it to false as the default value, and then basically go through, let's see, object.keys of object. So these are all my keys. So in this case, it'll be wheels, an array of wheels, brakes, helmet. And then I'll say 0. I is less than keys.length, I plus plus. And then I can say the value is keys I. Say if value won't it clash to have a function and a variable with the same name? Yes, actually it will. Great point. So I'll just call it a Boolean, or like result or something. And then I can say if value so if value is falsy, then actually I might not need this, because I might not even need this actually, because if it's falsy, then I just break out and I return false. Else I return true if I'm iterating through it and I'm done. And so I don't think we need this actually, but we might. So let me just keep that for there for now. But yeah, if value is just a falsy, or I could just even be more explicit, because value might be some other data type. So if it's false, then I'll return false, else I go through everything, and since this condition was not met, it'll be true, so I can just return true. So this should work for this first case. And then so it's always good to start simple. The reason I didn't use an for each, a lot of people might just say like, oh, this is a shortcut like for each, because this will give us the array of all the keys, and then we can get all the keys like that instead of having to do a for loop. But I like to just keep, I like to use a for loop just because we can break out early. And in a for each, you can't really return, or it won't return from the outer function. It'll return from the inner function that you're passing in. So we won't really get what we want in terms of the entire outer function being returning. So in this case, we've solved for the first case. Now let's get a little more complicated. So In the second case, sales, the value is actually an object. So I can say, let's see here, else if the type of value equals object, then I need to do something else. I think this will be my recursive case. And so, let's see. So if the type is object and this whole thing returns true, then I can continue. Else. So then I guess in this case, we can do something like if all systems go object equals false, return false. And then else, if the whole thing returns true, then we can't return this function call just because that just means that sub. So like, let's go to the examples. So in this case, if calling the function on this returns true, we can't say that the entire function should return true. We can just say we keep going, like we don't do anything if that returns true. Just keep going to the next key, and then we have to check that key, and then we go to the next key, and then we have to check that key. So this may not be what the solution, like this, if you guys look at the solution, there may be a more succinct one, but this is another way to go about it. Is basically if the type of that value is an object, then we're just gonna try and unpack it even more by just calling that same function on it. And then this sub function should result to either true or false. The reason I can use it here as a Boolean value is because it'll return false or it'll return true, that nested recursive call. Let me just see if this even works. Okay, so there's some specs that are failing. Expected true to equal false. Returns false if a system is not ready to go. Let me see what spec is failing. The fourth one. This function returns Boolean. It returns simple system. It returns false if some system is not ready to go. So let me see what bicycle dot helmet equals false. If value equals false, return false. That's weird. Let me just check what the values are. Value. Oh, right. It's just the key. So I need to say if the object value equals false, else if type of object value, then we pass this in. Yeah, cool. All right, so we're getting closer. I think we passed that fourth one. Oh, maximum call stack exceeded. Okay, so I think we're getting closer. We at least fixed that issue. But now I think our base case is not being hit. So let's see. Let me see which spec. So the fifth problem, which is probably, let's see, 1, 2, 3. Is a recursive case supposed to take the original array? I think it's an object though. Oh yeah, you're right. You're right. You're so right. Thank you so much. Because it needs to. Yeah, cool. So thanks, Arthur, for that. But I was basically not unpacking it. I was basically calling the function over and over on the same object. I wasn't getting closer to the base case. And in this case, the base case might not be um, as obvious. Like, oh, if the array length is 0, or if the object is, um, or if the string is empty. It's more like the base case is when we have an object that doesn't have any nested objects in them. Um, but yeah, just to further explain, uh, essentially, step one is we always want to solve for the simplest case where it's not even recursive. Like, don't even think about the recursive case. Let's just try and solve for the simplest case where there's no nested objects. And then we can just like use that function to basically call that same function on nested objects, because essentially if it encounters another nested object, it'll keep doing the same thing. And because we have these return values here, return false, return true, we know that calling that function is going to return true or false eventually. And so that's why we can use this in this conditional right here. And basically, in this case, what happens for the sailboat case, let's just walk through it. So in the sailboat case, we call the function on sailboat, and then it goes through the keys, right? In the for loop, it'll go through radio and sails and steering. But the interesting thing is when it encounters sails, it hits this else if. It says type of this sails value is another object. So the first function call, so first we called all systems go on the sailboat object, right? But that didn't end yet. It's still stuck on that first iteration, or that first key iteration. So then on the call stack, we call all systems go on sailboat dot sails. And then so the first call didn't end yet. We call this one because that's the first key it encountered, and then it encountered this case, and so it calls this again on sailboat.sails. In sailboat.sails, it's awesome because it doesn't call another recursive function. It just returns true because it went through main and jib, and none of them are false, so it just returns true. So this will just return true. And so all systems go object value will be true and not false. So then it doesn't do anything. It just goes to the next iteration, which means it goes to all systems. So this gets popped off the stack because it's done. And then we're still working on this. And then this will go to, it'll evaluate sailboat.radio, and that doesn't make a recursive call. It just continues the for loop, and then it goes sailboat.steering. And then this one does make a recursive call. So it calls all systems go sailboat.steering. And this, sorry guys, and this returns true because just like how it happened with sails, we just call the same function on the tiller object, and that'll return true. And then so this case is never met. And so we just continue on, and the for loop is done at that point. So then we just return true from the entire function. Like this one gets popped off the stack, and then now we just return true from the initial function call on the sailboat object. Does that make sense to people? This kind of array traversal, object traversal, would be pretty common in terms of, figuring out how many layers deep an object is, or maybe you'd want to flatten a nested object. This kind of use case, I feel like, would be somewhat common in the real world. Although in the real world, somebody already made a function to do it, so you could just use theirs. Great call out. The juice is on. Great catch. Yeah, today I was just really busy day at work, and then kind of lost track of time a little bit. Sorry, guys. But are there any questions on this problem? All right, let's move on. Oh, okay. So Jackie, going over Jib, if Jib was false. Awesome. Yeah, so if Jib was false, this is what would happen. That's a great question, by the way. So all system go sailboat hasn't returned yet. It's simply still in air. It's still being evaluated. But before it's done evaluating, it calls all systems go sailboat dot sails, because sailboat dot sails is another object, and then that case where it's an object, we call the same function again. Now Jib is false this time, so when we do sailboat dot sails, this is gonna go, check sails dot main in the for loop. In the same for loop, it's gonna say, oh, like value. This is gonna be true for check sails dot main. Value will be true, so it won't return anything, and then it'll just go to the next item, which is sales.jib, and then sales.jib in this case would be false, right? So it would go into this case, object value equals false. Can you change the view to vertical panel so we can see more of the code? Okay, yeah. Let's see, how would I do this? Change view. Full page view. Wait, hold on. Let me just remove this for now. And then, do you want me to just move this down, maybe? And then I can zoom in a little bit, maybe. Is this good, Raymond? If not, just let me know. But basically, yeah, we checked sales.jib, and then that will fall into this case. Sales.jib is going to be false, so it returns false. So this function, all systems go sailboat.sales, the whole thing just returns false. And so that function now resolves. So this function call, this recursive function call is done now. It resolved. And this function resolved with a value of false because Jib was false. So this whole function call can get basically replaced with the value false, since that's what it returns. And so basically we get like this whole thing becomes false. We pass control back to the outer function, and then it just becomes like false equals false. And then we return false from the outer function. So this whole thing becomes false, and now this whole thing also becomes false. Because one false just makes every single layer will return false. So even if, no matter how deeply nested this was, let's say there was like multiple levels, like say this called all systems go sailboat, level 1, and then that calls, it was crazily nested even more to call level 2, and then this calls level 3, and then just one of them returns false, then the whole thing will return false because this returns false, and then that passes this false value up to the one that called it, because, you know, all systems go 2 called all systems go 3. And then when all systems go 3 resolves with the false value, all systems go 2, this becomes false for all systems go 2 from its perspective. And then it returns false all the way back up the chain. So this one returned false, back up to this one, back up to this one, back up to the original one. And then it just, the whole thing will return false. Does that make sense? Cool. Yeah, it's definitely challenging when you start mixing in for loops with recursion, but I think you really solved half the battle when you just solved for the simplest case, and then try to like see that this is really just, you can use this to solve this nested object, and then you can use a solution for one problem for this nested one, and then for the entire outer one as well. They're all just like small sub problems of each other. And so usually a type check to see if that value is an object, and then recursively calling it again in that case works. And again, like I said, there's never a rule, a hard and fast rule. There's only like patterns, and usually there's a base case for simple recursion problems. There's like, if there's a simple base case, but in this case it's a little more nuanced, where it doesn't just it's a little bit of a different variation. But essentially, because for the simplest case you either return false or true, basically every recursive call is going to return a Boolean as well. So you can just use a recursive call. You can just depend on it returning a Boolean, and that's why you can use it in this conditional. So cool. Let's just keep going over some more. I think there's similar patterns to this one. Hopefully I have as much luck with other ones, but if you guys see anything and want to point things out, feel free, because I know Arthur and Raymond helped out a lot with this one. So yeah, feel free to help out with the other ones if you guys see anything. So that is this problem. We'll go to the truth counts. So this one's arrays. So it's kind of similar, I think. Accepts a multidimensional array of values, the truth count should return a count of all the truth values. Okay, so this one's a little different because it returns a count. And so let's see if there's any like really simple cases. Yeah, so this is the simplest one. So again, let's just solve for the simplest case where it's not even recursion, right? So it takes an array, and if we're gonna return a count of something, usually a good first thing to do is just create that, instantiate that with a default value. And then here we'll say, so it's just right here. Let's just take this as an example of the first one. So in this case, we would probably just do a simple for loop through the array. And then we'll have the value be array at I, and we'll say if value, if it's truthy, but let me think real quick. I might run into some issues later with this because value might be an object or another array, but let's just roll with this for now, just because we're just solving the simplest case first. We're not trying to even think about the more complicated cases. So if value, meaning like this will just be converted to a truthy value since it's a string, then we'll just do count plus equals 1, and then we'll just return count right here. So I'm just going to cover all my bases, and I'll say if type of value does not equal, and array dot is array value, it's not an array. Because an array, I think, is going to be truthy, so it'll mess things up. So yeah, this is the simplest case. I believe it'll work for the simplest case right here. So let's just try it out. It should pass 3. It should pass 3 tests. Cool. So now we need to do the recursive case, and it's really important to look at the type that you're returning. So before it was a Boolean, so I could just use it in a conditional, like if that recursive call equals true equals false, because we know it's a Boolean. So in this case, it's a number. So we know that every recursive call is going to return us a number. So it's almost like we can just add the recursive call to count, if that makes sense, because it's going to be a number. When we call the function recursively, it's going to give us back a number when it eventually resolves. So I would then do something like else if array dot is array. And the way that I'm ordering my conditionals, that you could probably order it in a better way, but I'm just going to handle the recursive case here because I don't really need to handle the falsy case, because it's not, if it's falsy, it shouldn't do anything. It shouldn't add to the counter. So in this case, I could maybe do something like count plus equals the truth counts value. Let's try that out. Cool. So basically, an explanation of this is we have, in this case, it's pretty straightforward. We just never go into this case. And for every single item in that array, we just increment or keep it the same. Now it gets a little more interesting when we have this nested array. Let's try this wacky one right here. So in this case, we call the truth. I'm just gonna call it the truth counts as short, and then it's gonna pass in this array. So we'll just call this array 1. So we'll call it on array 1. That, unfortunately, that'll go into this case because, or initially it won't. Initially, the first item will be 1, and then it'll be truthy, so it'll just add 1 to the count. So the count is going to be 1 so far. And then the second time it calls the function, the second element is going to be an array. So it's going to go into this case right here, and then it's going to recursively call the function. Sorry, guys, let me remove that. So it's going to recursively call the function. So now we're going to call TTC on array 2, which is basically, array 2 is this array. Right, so basically we're saying count plus equals TTC array 2. And then TTC array 2 is going to have, it's going to, it gets really tricky now because you have, the first one is going to be true. So our count is going to be 1. And then it's going to have another array. So it'll be like, count will be 1 plus TTC. and same here, it's basically gonna be 1 plus, because the first one was 1, so we'll just say like it's 1 plus TTC array 2, and TTC array 2 is gonna be 1 because its first element was just truthy, so it'll be 1 plus TTC array 3, and array 3 is this array. And thankfully, that array is just a flat array. So it'll basically result to 1, 2, and 3. So this will become 3. And then we'll go here, which is going to add another one, which is going to be 4. And then that's it for array 2. So array 2 is the whole thing is going to be 1 plus 3 plus 1, and it's going to result back out here, and then it's going to be 5. And then we're going to have to do another array. So it's going to be plus TTC array 4, which is this array. And that's going to, this whole thing resolved already. And then it's going to call TTC array 4. And then within that function, it's eventually going to return 1. It's going to return 1. And then so now we have 1. And then the whole thing's done at that point because we're at the end of the array. So just a good thing to think about is whatever the outer function returns, whatever the most simple version, whatever that value is, the type of that value, chances are you're going to just use that function call as interchangeable with that value type. So you can, if it's a number, you would add or subtract. If it's a Boolean, you could check a conditional, and so on. So Arthur asks, why do we check this value in the first if? That's because we don't count this. If we didn't do that, then we would count this as truthy too. So because an array is truthy, so in that case, we would kind of double count things. Like this should be 1 plus 2 plus 3, but then we would be counting 1 plus this entire thing is truthy, so it'll add 1. And then actually it won't even go here because this is an else if, so it won't even, if we didn't have this, it wouldn't even go into this case. But yeah, Raymond hit the nail on the head that arrays are truthy, so we only really want to count truthy values that are not themselves arrays. So yeah, just quick thing to note, whatever return value, whatever the type of that value is, it's like a hint that you can use that type in the recursive case. Just take advantage of the fact that you know that calling that function is going to eventually return to you a type that matches what you return from the most simplest case, if that makes sense. And so that's kind of like a hint. Like if you know it's going to return a number, you can do stuff with the recursive call. You can just kind of pretend like that recursive call is actually that number. So May asks, could I have written count plus plus on line 11? I think so. To be quite honest, I'm not 100% sure what the differences are. I tend to just use this to be safe because that's basically shorthand for, count plus 1. But I know that you can also do this too. And that, for the most part, does the same thing. But yeah, I just like to reassign. It makes me feel safer because I don't think this reassigns. I think that actually that has to to be honest, I'm not 100% sure what the differences are, but I'm sure that this also works. Let me see. I drag this guy up. If I lost it, let's see. Oh, there it is. Yeah, it still works. Yeah, it's a little more clear, and you could look it up. I'm not 100% sure. I know that there's some nuances to it, but um, yeah, let me think. Yeah, I would just look it up, but I just usually default to like this or like this. Yeah, but in this case, it would have been okay either way. Cool. And it may seem like I'm taking a long time to review these, but don't worry. Today's lecture isn't really even a lecture. It's more I'm going to go through the environment with you guys. So don't worry if this seems like it's taking a lot of time. It's not. Yeah, there's not really concepts that I'm teaching today. It's more just getting you guys familiar with the environment and then letting you guys take that practice exam and then figuring out how much time you guys have to take that second exam. But I'm not too sure with COVID and everything how if they're even taking applications right now for in person. So yeah, this is all stuff that admissions would probably be better to ask in terms of logistics. But let's keep chugging along here. Are there any other questions about this? Any other examples that you guys want me to run through for this particular one? If not, let's just keep going. So get longest name. So this one, let's see. It returns the longest name, and the names are all going to be keys. They're never going to be values. Let's see. So yeah, I want to just get a really simple one, but they only have a complicated one. But I think this case still stands. Let's just make an example of a really simple one to solve first. So we can have Arthur null, and then Raymond null, and then Elizabeth. I'm just gonna say Ellie for short, just in the interest of my fingers. And May. So let's just do this simplest case and then move to the harder ones later. Just I think for any problem that you encounter, it's always good to get some quick wins. So yeah, in this case, the shortest one or the longest one would be Raymond, I believe. So how would we solve this? Let's see. Get longest name. And usually when there's like something like longest or shortest, it's usually a hint that you'd want to essentially assign something and then reassign as you iterate through, reassign that longest or shortest name. So like for example, we could just say let longest name like equal to be an empty string initially, and then as we iterate through the object, we'll gradually replace the name. So I mean, for this, yeah, we'll just keep an empty string for now, and then as we see more values, we'll compare it to the longest name, and if it's longer, then we'll replace it, and then if it's not, then we just won't do anything. But the key here is to set the default value to be, if you're looking for something that's the longest, you should set it to like the shortest. So like if this was like get the minimum or get the maximum, then you should always like if you're trying to find the maximum, then you should set the minimum as your default, because your first element that you search through is gonna usually just replace this default no matter what. So you kind of want to set the longest to be the opposite of you kind of want to set the longest to be the shortest and the shortest to be the longest initially, just so that when you iterate through, usually the first element will like replace your default. But yeah, if that didn't make any sense, I think it will as we go through this problem. So again, I'm just gonna say my value, my names is gonna be object.keys of object. So this should return to me just my array, just an array of Arthur, Raymond, and you guys, and so on. So now I have that array, so this becomes pretty straightforward. I just go through I++, and then I say, let name equals names I. So I have that name, and I'll say, if, does anyone want to volunteer? Like, what should I be comparing in this case? In order to, to figure out if I need to update this value or not, if I need to replace it with the intermittent longest name. Yeah, that's exactly right. Thanks, Jackie, for your help. So do something like this. Yeah, she was fast with that. So if it's longer, then I'll just replace my longest name to be the name, and else I won't do anything. And then here I could just return longest name. I think it returns a string, right? Yeah, it returns a string. So that will be our simplest case. Now, if it's not, let's see here. Let's figure out how this recursive case goes. To brain melter a little bit. So it will return a string of the longest name of that object. So if it's not, so if names, so this could be a string. Well, it's always going to be a string actually. But in order to see if we need to go deeper into the object, we need to check the value actually. So let's see. And then we could say if name, if object name, if this is an object, usually for recursive cases to figure out whether or not you need to recurse. And if you're working in objects or if you're working in arrays, there's a pattern here. Like you check if that value is an object, or you check if the array.isArray of that element is itself an array, to know if we're going to need to recurse on this. So if the type, so we're doing the check regardless, because this is always going to be a string. It's going to be Arthur and then Raymond. But then let's do the simplest nested case where this is just one level deep, and then this has Elizabeth, which will be the new longest name, Elizabeth, and this is null. So it's just one layer deep. So we'll say, oh, like so right now we set the longest name to be Arthur initially. So, we called get longest name on object 1. And then the intermittent value of the longest name is going to be Arthur for now. but then because we set this, right? But then, you know, Arthur itself has an object that, so we need to check the longest name of that. So we'll say if, and we know that that returns a string, so we can say uh, if get longest name of object name, if that, so we know that's a string, so if that dot length is greater than longest name dot length, then we can say longest name equals, we'll say let, what's a good name for this? Nested longest name is going to be this. And then if nested longest name dot length, then this will be nested. I just didn't want to do a bunch of repeating object, like accessing properties. So I just wanted to give it a variable to keep it clean, and then it'll return longest name. So this may or may not work, but let's just walk through it in this case. So in this case, first we have Arthur. We set Arthur as the longest name here. Let me just put this down for you guys. Right? But then here we go into this case. So we set the longest name of Arthur in get longest name object 1. But then unfortunately, Arthur, the value of Arthur is another object. So we need to call get longest name on object 2. And this object is going to return this function call is going to return a string, because the type that the function returns for the simplest case is a string. So even for recursive cases, it'll still be a string, because it'll eventually unwrap down to the simplest case. That's the idea of recursive calls getting closer and closer to the base case in terms of the parameter that they take in. So get longest name of this object is going to be Elizabeth, because it'll go through and it'll set the longest name to empty string, and then it'll get all the keys, which is just Elizabeth in this case. It'll iterate through and it'll say, oh, like name.length is greater than longest name.length. And that's true, because longest name would be empty string for this function scope. We're not even talking about this one. We're talking about this nested recursive function call. And then it won't even get here because we're done. That value is not an object. So we just return longest name, which is Elizabeth. So this returns Elizabeth, right? And then here we do another comparison. We say, now we've finished this nested function, this recursive call, it returned Elizabeth. And so now this thing becomes Elizabeth. And then we do this check again, and then we replace. So eventually this gets replaced by the longest name of the nested object. And let me see if it works. So I'm not just making this all up. How did I get that? Thought I left a little space so that I can pick it. There it is. All right, beautiful error. There's some syntax issues here. Unexpected token. Oh, maybe this thing is. So remove that. Dang it. All right, so cannot convert undefined or null to an object. That's weird. So it's trying to convert something to an object. So it passes this one. Get longest name of family. So this is an object. let's just see. I'm just gonna log. When all goes wrong, gotta just see what the log is. So name and value. Cannot convert undefined or null to an object. If type, okay. So I'm checking here, but let's do object name. Okay, so Rudy Cook values objects. Name value is null. So null type of null equals object. Oh, I wonder if null is an object. Let me check it. There's some weird nuance to JavaScript that sometimes I think. Oh, that is tricky. Okay, so we can't use type of. I mean, we could say or something like that, maybe. I'm all out of whack here. Where is it? There it is. That was very tricky. But yeah, I think null is an object in JavaScript, so that's why I was failing. Just a little JavaScript trivia, I guess. But yeah, does anyone have any questions on this problem? It's pretty similar to the other ones. You should use the return value of the function as a hint as to how to use it recursively, because essentially calling it recursively will eventually get you the same type that this returns. I think I repeated this a lot. All right, we good to go to the last one? I'll take that as a yes. I hope this one doesn't beat me up, because it seems like most people had trouble on this one, and so this one's probably tricky. Okay, so function search party accepts a name and a world object. The keys in the world objects describe a location. Full stack subway. Okay. The values can be a combination of strings, arrays, or other objects. So many different types. That is annoying. So it can be strings, arrays, or other objects. Search through the whole world for a given name. Return an array with directions to the person if you find them. Full stack 25th floor. Null. Yeah, this one is tricky because there's different return values and you have an array and you've got to figure out where you... It's kind of like a... let's see, values can be some name, one name. Yeah, it's kind of like a breadcrumb almost, where the deeper you go, you constantly append to this array, and like, yeah, with each recursive call, you're essentially adding something to that array as like a trail for where you are or how you got to where you are. And then at the end, if there's no more to search, I guess you check if that name is found, and if it is, then you return that breadcrumb or that trail. If not, then you just return null. So yeah, again, I would go for the simplest case in this case, where essentially we have, let's see. Let's just let world equals just one, full stack. And then this just has the name we're looking for, so Jackie. I think this is valid. This is legal. So search party. It has a name and a world, right? So we need to traverse through the worlds. Okay, so the world is going to be, let's see. So we need to go through each, we still need to go through each key in this world object. So let's just say, let direction array. Just keep this as an empty array for now. And then we can just say let locations equals object.keys of world. So these are all my locations. Right now it's only going to be full stack. And then I'll say for let I location. This is kind of similar to how I've been doing the other ones. I'm just going to try it out. So we have, right now we have, the locations will just be full stack. And then here we say, for each location, so we're traversing through full stack right now. So our array should contain full stack at this point. Let me think though, because yeah, we have direction array, and then see how many arguments that this takes in. Simple world to equal bedroom. It only takes in 2 arguments. All right, so let's just, I'm sorry, I'm getting sidetracked with the more complicated case. Let's just solve it for the simplest case. So if, so let's say let value equals location, world at, or we can just say let location equals locations at I, and then let value equals world location. And so this is going to be Jackie for the simplest case. And then we can just say, if type of value equals string, or type of, or if it's an array, if it's an array or a string, we know that we're kind of at the end and we don't really need to call any recursive things because we're just checking the name at this point. Or actually, hold on. Let's just do the string case first. if value equals name, then we need to return something. In this case, we need to return the direction array. So here we would probably or let me think, return direction array or return location, because location right now is going to be full stack. So we could just return that. So yeah, this works. I think for the simplest case. Let's work up from here. So if value equals name, else, I'm just going to handle the array case because that's also not recursive. Else if type of, or else if array dot is array value. So if it's an array, then we still need to, then we do a little bit of different check. I think it's like if, we could do it many different ways, but I'm just going to say if index of the name does not equal to -1. So if there is an index in that array where the names are matched, then I'm just going to return location. Else, if I've gone through everything and I haven't returned anything, then I think I can just return null in this case. Yeah, so I think this will handle the simplest case. Let's go one level deeper. So full stack, and then where else in full stack is she? She's at, or what are some of the simple world, New York City, Manhattan, Uptown? Okay, so full stack, 25th floor, and then Jackie's there. For array.isArray check, can you say if value.includes? Yeah, I think that works too. They both use a for loop under the hood, so I don't think either is, I don't think there's a preference or a difference which one you use. So let's walk through this here. So if full stack, if it's not a string, it's not an array, and then if it's if type of value equals object. So if it's an object, then we're going to need to recurse somehow. So in this case, it's an object. So let's just walk through the tricky case here. So object.keysWorld is going to be full stack. Location is going to be full stack. Value is going to be an object that has 25th floor, and Jackie, that's going to be the value. So type of value is not a string. So we go to type of value is not an array. So it's we go into this case, type of value is object. So we need to call the function again. So we essentially pass this world in with the same name, but we need to return, we need to append it to this location, just because otherwise it'll just reinitialize the direction array as an empty array, and then it'll return 25th floor only. It won't return the other stuff appended. So I think we need to concatenate something like return location dot concat, and then the search party name, and then the world is going to be the value, the new value, which is going to be this like nested object. That should work for the easiest case, the simple scenarios. I mean, not easy, but the scenario where we do find it, we do find. Or wait, actually, we don't know if we found her actually. So let's see. Because I think this works if we find her. So if we find her, then we return the location. Else, if we return null, then this would become null, and we would just concat the location and null. Oh, I guess we could do a check here to say if there's a null in any of the levels of location or the direction array. Return location direction array. Yeah, so maybe we want to return because do you guys kind of see the problem here is basically there's two different, that's what happens when there's two different return types. Things get a little trickier because I can't just concat this because it might give me an array that has locations and then null as one of the values, and then we want just regular null. We don't want the entire. So like, for example, if this wasn't Jackie and we were looking for Jackie, let's say we were looking for Jackie, but this was, just Elizabeth, then we would be returning full stack 25th floor null, I believe, or 25th or full stack and then just null as the array instead of just null, because we're concating, we're just expecting this to be an array, but this could just be a null value too. That's what makes this a little trickier. So I think I could do something like, push to this array and then basically try to check if that array has a null in it somewhere, and then if it does, then I'm just going to return null. Else I'm going to just return this array. So instead of doing this, I could do I mean, I think this is fine. I think for this case, I would do something like direction array dot push location. This might be a little messy, but and then direction array equals array dot concat search party so I'm concating that, and then I'm going to say, if direction array dot includes null, then return null. Else I'm going to just return direction array. And that's only because if it's an object, so if I did find it, right? If I did find it, then I'm fine. I can just return the location, and then that works out perfectly. If I don't find it, then, or if direction array includes null, or direction array dot length equals 0. So if we never push to the direction array, or the direction array has a null value, because this could technically result in null, or it could result in an array. Sorry if this is really confusing. I understand that this is tricky, but I don't want to harp on this too much, just because a problem like this where, you know, there's multiple return values possible, return types, that's pretty challenging, and I wouldn't stress out too much about problems like this. But yeah, there's probably a cleaner way. I could just probably use direction array somewhere here, or direction array push. Yeah, but for now, let's just keep it at this. The solution probably has a cleaner solution. All right, so expected null to equal Manhattan, Midtown, Madison Square. Includes a null or direction array. Let's see what direction array is. Values objects. Yeah, this looks like it should work. Okay, it's putting nulls in because includes null dictionary. Let's just hone down. There's a lot of noise here, so I know that my fourth test spec is failing, so I'm gonna only run that test spec. It's like a decent strategy, I think. Whenever we're running with, you know, we have a lot of clutter. We just want to hone in on the ones that are failing. So we could just, you know, I think we can use it.only, and that will just only run. Wait, what? It only is not a function. All right, let me try this. Cross out everything else except the fourth one. Okay, cool. So now I can kind of hone down, clear this. Hone down on what exactly is happening here in this crazy function. Yeah, so I guess is it still running all of them? So uptown null, uptown, full stack null. So expected Manhattan, Midtown, Madison Square. I'm so confused by this output right now. Manhattan, Midtown, Madison Square, Susan. So I guess we're only looking for Susan in this case for the fourth one. Susan, New York City. All right. So we go into Manhattan and we call it on we call that function. So it becomes basically else this, and then we push the location, which is, yeah, I guess it's gonna be concat search value. So yeah, this is just gonna be Manhattan for now, and then we're gonna concat that with uptown, and that's just gonna be, we're not gonna find Susan there. So yeah, I guess we don't want to have some outer, because we're never going to be able to pop out when we go to the next key. We're not reinitializing it. Or maybe we just need to reinitialize this at each key. Because we know that if she's not in uptown, then we need to clear out the uptown key and then try midtown. So maybe in each iterate, maybe we do something like this. Set it here in the loop. Give it a go. So what does this want? Direction array is not defined. Oh, because it's in the outer loop. All right, let's just slow things down a little bit. I'm getting all sorts of confused. So here we have direction array concat. So let me just get rid of all this direction array stuff and just figure out the easiest case, simplest case. Because the null thing was really tripping me out a little bit. Return null. So if we haven't found anything, return null. Locations. We need this. Location not concat search party. Else return null. Try this. All right. So expected null. And then check console log what this is. Uptown, and then it returns null. So yeah, this is, I kind of see what I'm getting wrong is basically we go here to uptown and then it doesn't find it, so it just returns null. And then we do location.concat null. We return yeah, I think they took out the return here. But we return location.concat null, and then we just return uptown with null, and we don't keep going checking each nested object. All right, I think I get, all right, let's keep going at this. So let's go back to just the simplest case here. Let's not even do this. Yeah, so this one would work even for if there was other. So if this was, I just need to test more cases. So this is Elizabeth, or if we're looking for Jackie, but this is Ellie, and then this one is, Grand Central, and this one is Jackie. So if we're looking for Jackie, then this would still work because we go full stack, and then we don't find it. So we go to the next one now. We go to the Grand Central, and then we look for Jackie, and then we find it, so it'll just be Grand Central. So in this case, it works. It's only when it's nested that it stops working. So let's see. Nested. So Raymond, it looks like maybe we may need to check that we found the name, then maybe two location variables, current direction and final direction. Yeah, it's promising. So current direction and final direction. Yeah, that makes sense. So having like a final direction out here or something, and have the current direction be inside the loop, maybe. Um, let's see. Let's try that. So let final direction is an empty array. And then current direction is going to be somewhere in here. Let me try a different example here. So if we're looking for Jackie and she happens to be in an object, it's like third floor Jackie. Then we go here, we don't find it in here, so we move on to this one. And then actually we need to nest this one too. Yeah, this one's tricky. So we go here, and then so far the direction would be yeah, let me think. So if it's an object, then I guess we can reset final direction. I was kind of going along this way earlier. With each iteration, we just kind of reset everything. If we haven't found it here, then we just reset that array, and then we try to find it here. Then if it's an object, then we just do final direction dot push location. That's the current location, and then we say going back down this road again. I think this time it might be different because we're now resetting it each time, and then in the outer one, we'll have access to the outer one here just because we're setting it outside. Search party name world name value. And then, so in this case, it would be full stack, 25th floor. So first we'd go full stack, final direction would be empty, and then the next thing would be an object. So this would be, final direction would be full stack, and then it would be dot concat search party of 25th floor LE, and that would just return null, I believe. So our final direction would be this null. And then I guess here, before we go on to the next iteration, we would basically say if final direction if there's no null in here, then just return it. So final direction dot length and final I think in like a few minutes, I'm just gonna stop this because you guys maybe just be lost, and I'm also a little bit lost. But I'm like getting at what this is asking. And I think I'm getting closer, but yeah, I don't want to just belabor this. This is a challenging problem, and honestly, if you guys never get this, you guys can still be ready to apply because these are kind of just like interview type questions, and you definitely want to be prepared if you're going to do an interview for something of this difficulty. But yeah, I wouldn't say that this is like, if you don't understand this, then I wouldn't say you're not ready for the program or anything. But yeah, I'm just gonna try this out and then explain it if it works. But so if there's a length and it doesn't include null, then return it before even going to the next one, because then return the final direction. Else we keep going because it has null. We keep going in this for loop, and then it'll just reset it anyways. It's worth a shot. It's worth a shot. Dang. See a little green guy right there? It's a good little sign. So maybe we just try this rest of this stuff. This is actually a good problem. It's actually an interesting problem because it's like, it actually is kind of practical in some ways. Nice. That was surprising. But yeah, in any case, what's happening here is basically in this example, we have full stack, and so right now our location is going to be full stack, and then our value is going to be 25th floor Jackie, and the name that we're searching for is Jackie, or 25th floor Ellie. And let's say that the name that we're searching for is Jackie. Name is Jackie. So we come here, and then value is this object. So we go into this case, and we say final direction is we push the location that's current. So final direction is full stack. And then we concat the search party of this. And calling search party on this nested object is going to result in null, because we essentially set up the locations to be 25th floor. It's an array that just contains 25th floor. And then the value is going to be Ellie. And so this is not going to be true because the value does not equal the name. It's not an array, so we won't even go here. And then we're just done with that for loop because there's only one item in the for loop, and that was just this string, 25th floor. So we essentially return null from the recursive function call on this argument. So final direction is going to be full stack null. That's going to be our final direction. So now, before we go on to the next iteration and before we check Grand Central, we have to say, oh, like, is there a length, and does it not include null? Because at that point, if it did not include null, then we've already found our target, because nothing returned null. So there's no null in this array. So we found our target, and we just need to return it. But if this condition is not true, meaning that there is a null, meaning that was a fruitless search and there was no target in that particular object, then we just reset the final direction to be empty, because now we're coming back up and we need to reset everything because nothing's going to be related to full stack anymore. We're just searching Grand Central. And so now our final direction is empty array, and then our location is going to be Grand Central, and then our value is going to be 3rd floor Jackie. right? So then, we go here again and we say final direction is going to be Grand Central. And then it's going to be concat search party of this. And search party of this is just going to be, we're going to unwrap this and the value is going to be Jackie, which is equal to the name. So it's just going to return an array that's third floor. So it's just going to be like this dot concat of third floor, which just basically becomes Grand Central third floor. And then now we do this conditional. It does have a length and it does not include null, which means we found it because we've never encountered the null. And so here we just return final direction. Thanks a lot, Raymond, for that help. That was really helpful. Brought me back to my senses. But yeah, I wouldn't stress too long. I'm not going to belabor this problem because this is a challenging one. And it is cool, though, because you could see how it's a practical thing. Like maybe I want to figure out where my target is in this like deeply nested object and I want to find the whole breadcrumbs. Like I want to find the entire address of like how many properties I need to access before I get to this. It's a little contrived, but it could be some. I mean, I'm definitely not like everyday coding. You'll probably never encounter something like this, but theoretically it could, and it's kind of a cool concept. Like you're digging a hole. It's kind of like digging for oil. Maybe you're digging in like field A, and then if you can't find oil, then you just go to a different field and try digging in field B. It's kind of like that conceptually, which is I think is pretty interesting. But this code is definitely messy, and I would refer to the solution as a cleaner implementation. So yeah, that is it for the concepts for this class. So you guys have all made it through. And you guys are troopers are you guys even still there? Oh, dang, there's still some people. I thought some people might have checked out by now, but this is, you guys are amazing for sticking through this. Again, this kind of problem probably going to be never encountered on your daily job, but it might be asked in an interview question. It might be asked, you might like run into something where you need to use recursion to solve a problem, but 99% of the time you won't on the daily job, but someone might be mean enough to ask you some recursive problem similar to this. So I would definitely say, when you're job searching and just knowing this in general will be helpful just because you'll have more practice with it. But yeah, I wouldn't be deterred if you guys had a lot of trouble with these recursive problems. But definitely from recursion 1, those are kind of fair game for even the full stack interview. The more simple recursion ones, like sum an array, a nested array or something, those ones are fair game. But it wouldn't be something like this. Murphy's Law, yeah, I've heard of it. Oh, diminishing returns, is that kind of the idea? Yeah, I would focus on recursion 1 and just really grab that, and then the concept of the call stack, just really hammer that home. And for stuff like this where, okay, like I would just stay with recursive functions that just return one type, not potentially 2 different types, which is really gonna be tricky. Oh, Murphy's Law says if it can happen, it will happen. Yeah, so it can happen, and so it will happen, I guess. But yeah, let me walk you guys through the practice assessment. So I believe I've unlocked it. Actually, let me see if I did. BCP. Oh, this is remote. Oh, BCP month. Okay, so practice assessment. I mean, I don't know if this even has a workshop. I don't think it does, but now you guys should have access to the bootcamp assessment, which basically, if you guys go to it, it'll be this link, and then you guys can just go to this link. This is a practice one, so if you guys are tired right now and probably won't, because when you enter it into it, it's going to start a timer. So I wouldn't do it. I kind of went over today, so if you guys are tired today, maybe just try and do it. I think it's here. Let me go through the lecture real quick. Actually, sorry guys, these problems really drained my brain. But let's see. So next steps, there's practice assessments, because when you guys actually apply, and I'll answer your question, Elizabeth, if these slides answer it. If not, I'll point you to the right resources. But basically, the practice assessment, it's different than working in our environments that we were working in. It's a whole different environment, so it definitely takes some getting used to. And there's a time limit, so I do think it's a one-time only thing. Unfortunately, like when you start it, there'll be a timer. But for the practice one, it doesn't matter if you fail or do terribly, because no one even looks at that. So HackerRank, it's pretty commonly used. I mean, my first job out of boot camp, they gave me a HackerRank before they even gave me an interview. So it's kind of like some people use it as a way to just make sure you're serious about your craft and that you can code. So yeah, it'll provide you with a virtual tour, but I'll walk you guys through some stuff too, as well. It basically calls your code and passes test cases, and you guys can see logs. So for some, hides your console logs and the output of your function for some test cases. Yeah, so it's kind of a little tricky, because as your tests fail, for some of the failing ones, you'll be able to see your console, like you'll be able to log, but for other ones, you won't be able to, which is kind of weird. But I mean, chances are the problem that you get, the test case that you're stuck on, you'll be able to see the logs, but there might be a chance that you won't be able to. And in that case, I mean, it really just helps to try your best and at least put some comments in where you're stuck. If you can't get like one test to pass, that doesn't mean you're not going to get an interview, because chances are, like, if there's a few tests that fail, you'll still get an interview. So I wouldn't stress too bad about that, but definitely write some comments in and try to make the code as clear as possible. And it doesn't allow you to open another browser window. I think you can open one, but I think it will alert whoever's gonna assess your test that somebody opened it, that you opened multiple windows. So I would refrain from doing that. So they're usually 4 to 6 questions, and they have a 75-minute limit. So these practice ones, so you guys will have 2 practice ones, one that you can do today or tomorrow, I believe. Let me just make sure with people first, though. But yeah, I mean, I don't see why you wouldn't be able to do it tomorrow. And then there's another one that you could do that could count if you want it to count. And so they have 75-minute time limit, and so it's good. And they usually go from easy to hard. So if you guys get stuck on one, it's good to just, I mean, it's good to just move on and try to solve as many as you can and come back to that one. But usually it's good to start from the easy ones first, just so that you can get like some quick wins in. So yeah, there's one that's already released that you guys can go to right now. And click around in it. I'll walk you guys through the environment, but you can do whatever you want and we'll never look at it. But I believe you can only take it once um, because there's a timer. But there's gonna be solutions anyways. So if you guys, you know, run out of time, you can still look at the solutions and figure out what the problem is from there, and then just keep practicing like that. So yeah, there's another practice assessment that you can take after class, and we'll look at the submissions for this assessment. If you do well, you can skip the real one. If not, then you still need to take the regular one. So it's not a big deal because you can still try it again, like apply as you would have normally. But this course just gives you a chance to skip all that. And so this you will take after this class. I know that some people are going to ask how long can I take this? What's the time period that I can take this assessment in? And I will get back to you guys. I'm not 100% sure, but I know admissions probably knows what that time period is, but I believe it's not, you don't have like forever to take the practice assessment too. So I would just take it, shortly after this class, but I'll find out for you guys what that time limit is. In terms of JavaScript, these you can read this book. It's helpful. It's free online, so you can take a look at that, take a gander. But I would really just more so focus on some of the challenging problems that you guys ran into in this class, and then just go through those problems. Make sure you have a solid understanding before you start like referring to books and like things like that, just because it can be a bit of a time sink. Code Wars, again, great resource for problems, but some of the advanced ones, they're really just might be a waste of time because there's just more pressing and fundamental concepts that are more important before you get into the fancy stuff. So Project Euler, I've never looked into this, but yeah, if you want to improve your logic and mathematical thinking, that never hurts. In terms of long-term growth, this will always just come and benefit you guys. So if you guys have, a desire to improve these aspects, then by all means, take a look at those. And yeah, I mean, it really helps when you guys do personal projects because really you learn things by doing. So, if you guys have time, you can essentially build out some of these games on the side, and it's a little more fun too because it's not just solving some problem, but you actually make something that you can play, which is cool. So yeah, these slides are going to be sent out to you guys, so you guys will have these. But any like logistics related questions, I would point to these contacts. And yeah, you guys definitely can do it. It's hard, it's not easy, but if you just keep practicing the problems, then eventually, I believe you guys can be successful. And yeah, that pretty much wraps up the final mini lecture. I will quickly go over the HackerRank environment for you guys. So let's see. We have this guy. So when you click that link that's on the full stack page. Yeah, this one. you'll be taken to this page, and then you just click continue. And then there's 5 questions. It'll give you all these setups, and then here I'm just gonna do this like random email because I already did this, and it won't let me use my same email. Damn. So that email was taken. So you have to say that you're not going to copy, and this will be what you guys experience in the actual test too. So just saying you guys are going to be honest about the test, and you click start test, and then this is what it's going to look like, the actual one too. Again, this is the practice one, so you don't have to really be stressed at all about it, but there's a timer. You can hide it if ignorance is bliss, but I would probably recommend not hiding it. And then here we have questions, and they should be an increasing difficulty. I don't know if this one is, because is prime is actually might be hard. So sum evens only, you go into the first one. I would go step by step, and then it gives you like all of this walkthrough, so you guys can adjust the slider, programming language, blah blah blah, code editor, autocomplete, settings, run code to test against test cases, and there's submit. So there's 2 different things. You can run it to check all that it passes the test cases, and then submitting it will actually submit it. So you could submit an incomplete one too if you run out of time. But yeah, if you guys, let me see how you go back. Yeah, so you guys can toggle between problems like this. So I would only submit really if your tests are all passing, or if you're running out of time, then just submit it. But if you can't get this problem, then go to the next one, and then just try this one. Does an actual person assess this, or is it just looking? Yeah, an actual person will look at it. So you don't need to get all of them 100% right to get an interview, because it's just a person that's assessing it. So yeah, if you get all 6, then you're gonna get an interview. That's definite. Should you brush up on math concepts? I personally, it's the extent of how complicated. The is prime one, it'll explain to you what a prime number is. So it'll say a prime number is a number that is greater than 1 and is only divisible by itself and the number 1. So it'll explain things to you. So I wouldn't really brush up on math concepts other than even, odd. Yeah. So for this one, yeah, that's great. Just math in general is just helpful. I feel like having that mentality of, just logical thinking and analytical thinking, but by no means is that necessary to be successful, because, if you have, more, qualitative skills, that is really helpful in the workplace as well. So, you need a good balance of people. So if you're not like, the mathy type, the typical engineering type, that's completely fine, because I'm not either. I really don't like math. But so this, you don't have to really touch at all. This main right here, just leave it be. And so here we'll just go through a practice thing. So like if you just wanted to console log, your range start, it should, because console logging is a really important thing. So for the most part, it does work, because this is what you guys are going to be doing a lot of when the problem doesn't get solved right away. So range end. So here we just can run, right? And now we get, the output is 1, 5. Our output is undefined. And, this is our debug output. This is where our console log comes out. And then when we run the test cases, it'll fail the test cases. I don't know why this one's taking so long. Yes, and then it'll tell you, like, it should tell you, oh, like this one is expecting not 90, you're getting undefined, and here are your range end and range starts, right? So for this one, it happens to be locked, but even then, you could still see your ranges. So you'll always see your logs, but this one test case happens to be locked. So yeah, it'll be a little tricky, but you'll always be able to see your logs, which is good. And yeah, when you're done with this, you just go on to the next one. If you can't, yeah, it'll tell you that you haven't submitted them, but you can still go back to it and it'll still have your code saved, like right here. So you can navigate away and then it'll still have your stuff saved. So don't, if you can't get this and you can't submit, just don't submit it. Go to the next one and try this one. Don't spend too much time on one problem because there is a timer. And yeah, that's pretty much it for the environment that you guys are working in. Let's see. And yeah, I mean, if you guys want to, I'll be available until 9:40 if you guys want to tackle this right now. I mean, I guess I would give it a shot just because we do have class until 9:40, so I would try to do this, and then if you guys have trouble, I'll still be here, so you guys can ping me and ask for help. But other than that, that's pretty much it. And then I'll get you guys. I'll get you guys info on when this needs to be done by, this assessment 2, because it's not going to be today, but it will have to be sometime soon. So let me figure that out for you guys. But yeah, just yeah, I would say just give this one a shot right now. I know we don't have enough time, the full amount of time, but we still have, you know, about an hour. So I would say give this one a go, and then after a quick break, and then if you guys, you know, run out of time or if you guys are tired, then I'm gonna open up the solutions anyways, and then you guys will be able to see all the problems. If you guys can't get to it all today, like forever, as long as you guys have access to this, you guys will be able to see the solution, so you guys can like, you guys can look it up. But yeah, just stay tight. Stay tuned for that last bit of info on this assessment 2. But other than that, yeah, you guys feel free to go ahead and open up and click around and try that assessment out. And I'll be available if you guys have any questions. No problem.